Understanding steam boilers. A steam boiler is a closed vessel that heats water under pressure to produce steam. Steam is a powerful and versatile energy source used in various industries. The boiler's core components. Water drum. This drum stores water and acts as a reservoir for the boiler system. It typically sits above the furnace and provides a space for steam separation. Furnace. Fuel is burned in the furnace, generating heat that is transferred to the water within the boiler to create steam. Economizer. This component preheats the feed water using the heat from the flue gases, improving overall efficiency. Superheater. The superheater raises the steam temperature beyond its saturation point, increasing its energy content and enhancing its efficiency for various applications. The steam generation process. 1. Feed water is pumped into the boiler drum, where it is preheated by the economizer, and then circulated through tubes inside the furnace. 2. Fuel is burned in the furnace, transferring heat to the water-filled tubes. As the water heats up, it turns into steam. 3. The generated steam rises to the top of the drum, separating from the water. Steam is then passed through the superheater to increase its temperature and pressure. 4. The superheated steam is then transported through pipes to various industrial processes, where it provides energy for power generation, heating, and other applications. Types of steam boilers. Fire tube boilers. In these boilers, hot gases pass through tubes surrounded by water. The hot gases heat the water, causing it to boil and generate steam. Water tube boilers. Water flows through tubes surrounded by hot gases. This design allows for higher pressures and temperatures compared to fire tube boilers. Package boilers. These prefabricated boilers are designed for smaller applications and are typically shipped as a complete unit. They are often used in industrial and commercial settings. Applications of steam boilers. Power generation. Steam turbines powered by steam boilers generate electricity in power plants. Industrial processes. Steam is used for heating, drying, sterilization, and other industrial applications. Heating and HVAC. Steam boilers provide heating for buildings, hospitals, and other structures. Transportation. Steam is used to power locomotives and ships, although its use in transportation has declined in recent years. Advantages of steam boilers. Efficiency. Steam boilers can efficiently convert fuel energy into steam, minimizing energy losses. Versatility. Steam has diverse applications, making steam boilers adaptable to various industries. Reliability. Steam boilers are known for their reliability and long operational life. Control. Steam production can be precisely controlled to meet varying demands. Safety and maintenance. 1. Regular inspections. Regular inspections ensure the boiler operates safely and efficiently. Maintenance. Preventive maintenance helps prevent breakdowns and ensures long-term performance. Safety valves. Safety valves are crucial for preventing excessive pressure buildup, ensuring safe operation. Emergency procedures. Operators must be trained in emergency procedures to handle unexpected events. Key takeaways. Steam boilers are essential components in various industries, providing efficient and reliable energy for numerous applications. Understanding their components, operation, and safety measures is crucial for using them effectively.